area of the quadrilateral. So as you can see, this is a cyclic quadrilateral, and there is a formula for a cyclic quadrilateral that the area of a cyclic quadrilateral is always equal to the square root of x minus a, x minus b, x minus c, x minus d, where a, b, c are the sides. And x is the semi-perimeter of the sides. So that's what you're going to use. I'll prove it after this solution. I'll prove it to take time, but let's solve first. So this is now equal to the square root of the semi-perimeter is now the addition of the sides, which are 6. Okay, maybe let me do semi-perimeter is 6 plus 2 plus 5 plus 7 over 2. So which is equal to this 8 plus 12, 20, so it's 10. So our semi-perimeter is 10. So I have 10 minus 6 is 4. 10 minus 2 is 8. 10 minus 5 is 5. 10 minus 7 is 3. So we now have, 8 is 4 times 2. So I have 4 squared times 2. 2 times 5 is 10 times 3. Okay, our answer is now 4 roots times. So that's the area. So which is option D. So let's prove this formula. Okay, from this diagram, see that it's the same as the former question, but now we use alphabet as the sides. So we want to get a general formula. So the first thing I have to do is I will add 2 auxiliary lines so that we'll complete the triangle. So we want to form a triangle using 2 auxiliary lines and the quadrilateral. So I've added that. So let me call the point of intersection of the 2 lines T. You can see that we have 2 similar triangles. Why? Because from the exterior angle of the cyclic quadrilateral, this angle is the same as this. Why this is the same as that? So we have 2 similar triangles. Yes. So we see that triangle. That triangle T PQ is similar to triangle TPQ is similar to triangle TRS. Yes, which implies that. Okay, let's call this the length here x. Let's call here y. Remember, we're not giving x and y, so let's counter it. Like, let's write x and y in terms of a, b, and c. And how do? You see that this side x, okay, let's use b of the small triangle corresponds to d of the big one, is now equal to, if you check, this 1 hash is opposite y of the small triangle. So check the big one. 1 hash is opposite x plus a. So we see that x is now corresponds to y plus c. Yes, as you can see, x is opposite double hashes y plus c. Y is opposite x plus a. Yes. So with that, we can form equation. So which implies that we cross multiply. We see that dx is equal to by plus bc. So so cross multiply, and also dy is equal to bx plus ba. So let's call it equation 1 and equation 2. So if we do equation 1 minus equation 2, you see, let's do equation 1 minus equation 2. And after we do the subtraction. So if we do equation 1 minus equation 2, you see that d is common, that's dx minus y, that's dx minus dy. So factor d is equal to by minus x. I factored b because it's common here, and b c minus a. I move this b bracket y minus x to the other side. We now have b minus b, because we can make it, so let's make it plus x minus y is equal to b bracket c minus a, because we can write this as minus b bracket x minus y. So if it goes to the other side, become plus. So if we factor x minus y, we are left with d plus b. So making it the subject of formula, I have b c minus a over d plus b. So let's call it equation 3. Again, if we do equation 1 plus equation 2, so we see that d x plus y, that's d is common, if you add, is equal to b y plus x plus b bracket c plus a. So we added. Again, if I make x plus y the subject of formula, we see that we have b bracket c plus a over d minus b. Yes, because this moves, b bracket y plus moves to the other side to be minus. So that's why it's d minus b. So let's call it equation 4. So you see the reason, because there will be a time we need to remove x plus x and y. So we use these substitutes 3 and 4. So coming back again, they are still similar. And we know that area, the ratio of areas of two similar triangles, is equal to the ratio of the squares of their corresponding side. So we see that area of the big triangle, which is triangle TSR, to that of the small one, which is TPQ, TSR, and TR. Okay, TSR and TQP is now equal to d squared over b squared. Yes, for similar triangle, ratio of areas equals is ratio of the squares of the corresponding side, because that they are similar. So making it the subject, or making the big one the subject of formula, we see that area of the big one, which is TSR, is now equal to d squared over b squared of the small one. Area of triangle TQP. Yes. Now we need to get the area of the quadrilateral. I'm looking at the diagram. You see that to get the area of the quadrilateral, you subtract the small triangle, area of the small triangle, from that of the big triangle. So we have therefore the area of PQRL, which is what we are asked to find. Now the area of the big triangle, that's triangle TSR, minus the small one, area of triangle TQP. And we've written the big one in terms of the small one, which is d squared over b squared, area of triangle TQP, so minus area of TQP. TQP. And we can factor. What is common is area of TQ, triangle TQP. So we are left with d squared over b squared minus 1, which is d squared minus b squared over b squared. Yes. And that minus 1 there. Now find the LCM. So now we need to get an expression for the area of the small one, that's TQP, after we substitute. So looking at triangle TQP, as you can see in the diagram, we have a triangle with 3 sides. So using Heron's formula, so we see that area of triangle TQP is, now we are using Heron's formula, the square root of the semi-perimeter, which is x plus y plus b over 2, times we subtract each of the sides from the semi-perimeter, which is x plus y plus b over 2 minus x times x plus y plus b over 2 minus y times x plus y plus b over 2 minus b. So that's what we call Heron's formula. If you remember, the area of a triangle given all the 3 sides, that's Heron's formula. Let's move to another page. Okay, we can write all so that they have the same denominator. This first one is covered, x plus y plus b over 2, while the second one is x plus y plus b minus 2x over 2. Third one is x plus y plus b minus 2y over 2. Last one, x plus y plus b minus 2b over 2. Okay. So as you can see, 2 times 2, 4, 4 times 4 is 16. So square root of 16 is 4. And I have 1 over 4 of. So we're left with x plus y plus b times. Now, you know, we are left with the numerators. So I can write this as b. Since I have minus x, I have minus x minus y. So we're still correct. Yes. Because we've gotten an expression for x minus y and x plus y. So that's why I left it in that form. Times we have b, because I have minus y, so I have b plus x minus y. Yes. The last one is now, okay, last one is x plus y minus b. So looking at this, we can easily see that if you check x plus y, this, which one has x plus y again? See, we have difference of 2 squares, so we can write this as x plus y all squared minus b squared. Yes. So taking this one, the first one and the last one, x plus y plus b times x plus y minus b, that's difference of 2 squares. So that's why the second is also, if you check b minus and b plus x, so we have b squared minus x minus y all squared. And looking at this, we can substitute. Now substitute the value of x plus y and x minus y. If you could remember, we've gotten the value as I want to write it in terms of B and C. Do you see it? So that's why we made x plus y and x minus y the subject of formula. So x plus y is b bracket c plus a over d minus b. Okay. So we now substitute. So this is now equal to 1 over 4 the square root of, substitute s plus y is now b bracket c plus a over d minus b all squared minus b squared, so that's it, times b squared minus x minus y all squared is now b bracket c minus a over d plus b all squared. Okay, so this could be written as this b squared c plus a all squared over d minus b all squared minus b squared times b squared minus b squared times c minus a all squared over d plus b all squared. So which could be, you notice they all have b squared. So if I factor b squared times b squared is b raised to the power 4. And again, if you look at this, their LCM is now d minus b all square. So what do? This is now equal to 1 over 4 times b, because square root of b raised to the power 4 is b squared over d squared minus b squared. Do you know why? If you look at this, the LCM is the product. So bringing out squared, why d minus b times d plus b is difference of 2 squared. So we now have square root of, so we are left with c plus a all squared minus d minus b all squared for the first bracket. By the second bracket, we now have d plus b all squared minus c minus a all squared. Also factored b squared out, so that's why it's now d squared minus b. You factor that. So this is equal to, let's move to the other page. Okay, this is equal to b squared over 4 times d squared minus b squared square root of this difference of 2 squared. So I have c plus a plus d minus b times c plus a minus d plus b. That's the first bracket, while the second bracket is d plus b plus c minus a times d plus b minus c plus a. So if you will let's x be a plus b plus c plus d over 2. That's the semi-perimeter. So we'll see that the area, therefore we'll see that area of triangle TQP is now equal to b squared over 4 times d squared minus b squared times the square root of, we can write this a plus b plus c plus d minus 2b. Yes, because we have minus b, so b minus 2b is minus b times a plus b plus c plus d minus 2d times a plus b plus c plus d minus 2a and finally a plus b plus c plus d minus 2c. So why do I do? So that we'll bring in this s. So we see that the area is now b squared over 4 times d squared minus b squared, all in square root of, we'll call this x is equal to the semi-perimeter. So if you make it the subject of, we should make a plus b plus c plus d the subject, we now have 2x minus 2b times the same thing, 2x minus 2d times 2x minus 2a times 2x minus 2c. And we can easily see that we can factor 2. 2 is common in each of them. So 2 times 2, 4 times 4, 16. Square root of 16 is 4. So we are left with d squared minus b squared. Because the 4 will cancel out the 4 down. Square root of x minus a times x minus b times x minus c times x minus d. So, but remember, this area of triangle TQP. So let's go back. You remember they've said that the area of the quadrilateral is d squared minus b squared over b squared times that TQP. So if you substitute, therefore, what we are looking for, we've gotten the formula. Therefore, the area of quadrilateral PQRX is now equal to, remember this, say this d squared minus b squared over b squared times the area of the triangle, which is b squared over d squared minus b squared of square root of x minus a, x minus b, x minus c, s minus d. So which is now equal to just the square root of x minus a times x minus b times x minus c times x minus d. So this is the formula for any cyclic quadrilateral. I told you it will take us time, but finally we've proved that.